Hi, the topic of this video lesson is formulas of reduced multiplication. In a number of cases, the multiplication of certain polynomials gives a very convenient result, and we should remember this result and use it in further calculations. Let's take a look at one example. Let's find the square of this expression, a plus b squared. We know that a square is a product of expressions by itself. And we know how to multiply a polynomial by a polynomial, so let's do it. A multiplied by a, it will be a squared. A multiplied by b, ab. B multiplied by a, ab as well. And b by b, b squared. Now we see that in the middle we have two similar components. So we add them and get the result. A squared, 2ab, plus b squared. We've come to a formula. This is our first formula of reduced multiplication. This formula is called the square of the sum of two expressions. It is read as follows. The square of the sum of two expressions is equal to the square of the first expression, plus twice the product of the first and second, plus the square of the second expression. Let's consider an example. Let's square the following expression. 2x plus 3y squared. Using this formula, we can write it as follows. The square of the sum of two expressions is equal to the square of the first expression, that is, 2x squared, plus twice the product of the first expression by the second, 2x times 3y, plus the square of the second expression, 3y squared. Squaring it, 2 squared is 4. X squared, multiplying here, twice 2 is 4, and times 3 is 12, plus 12xy, and plus 9y squared. Revealing this formula, we use the square of the sum. Note that we need this stage only at the first time. After you get used to the formula, you might choose to write only the result. Now let's take a look at another example. We need to square the number 81. How can it be done in the most rational way? We can use the same formula. Imagine 81 as the sum of 80 and 1. Now we have the square of the sum of two expressions. Let's use the formula. The square of the first expression, 80 squared. We have 6,400. Plus twice the product of the first and second. 2 times 81 is 160. And plus the square of the second expression, 1 squared is 1. Then we can easily calculate that it will be 6,561. Let's consider the second formula of reduced multiplication. This formula is called the square of the difference. The square of the difference of two terms. We can use the same method as in the previous examples. Multiply a minus b by a minus b, or substitute minus b instead of b in the previous formula. Then we get the result a squared minus 2ab plus b squared. This formula is called the square of the difference of two terms. The square of the difference of two terms is equal to the square of the first expression minus twice the product of the first and the second, plus the square of the second expression. Let's take a look at another example. Let's square this expression. According to the formula, we have the square of the first expression, that is 4a squared. So let's square it. 4 squared, 16a squared, minus twice the product of the first and the second. Twice the product of 2 times 4a is 8a times b, 8ab, and plus the square of the second expression. As in the previous case, we can use this formula to simplify our calculations. Let's consider an example. It is required to square the number 59. How can we do this? 59 will be represented as 60 minus 1 squared. We got the square of the difference of two expressions, and now we can use this formula. The square of the first expression, 3,600, minus twice the product of the first and the second, minus 120 plus the square of the second expression plus 1. That would be 3481. Let's consider one more formula. Let's multiply the expression a minus b by a plus b. What will we get in this case? We multiply according to the usual rule of multiplying polynomials. A by a squared, ab, minus b by a, minus ab, plus b by b, minus b by b, minus b squared. We see that the terms in the middle cancel each other. It turns out a squared minus b squared. After writing it in reverse order, we get the following formula. A squared minus b squared is a minus b, a plus b. This formula is called the difference of the squares of two expressions. The difference of the squares of two expressions is equal to the product of the difference of these expressions by their sum. Please note that this formula should not be confused with the previous one, where we consider the square of the difference. In this case, we consider the difference of squares. Let's consider an example. Let's say we have 9x squared minus 16y squared. Let's try to write this expression using the formula. 9x squared can be represented as 3x and everything squared. 16y squared we can represent as 4y and everything squared. We have obtained the difference of the squares of two expressions. Accordingly, we can use this formula. The difference of the squares of two expressions is the product of the difference of these expressions times their sum. It is also useful to know the sum of cubes formula. That is, we have two expressions, the sum of two expressions, and you need to be able to rise to the third power. How can we calculate it? We can multiply the expression a plus b by itself 3 times, but that would be inconvenient. Let's use the following formula. A plus b cubed is the same as a plus b squared times a plus b. But what is a plus b squared? That we already know. This is a squared. ab, b squared. It remains to multiply this polynomial by a plus b. We get a cubed plus 2a squared b plus ab squared plus a squared b plus 2ab by b, 2ab squared, plus b cubed. If we continue to work with the terms of our expression, we get a cubed, 3a squared b, plus 3ab squared, plus b cubed. So, we got this formula. A plus b cubed is equal to a cubed, a squared b, 3ab squared, plus b cubed. We can get the same formula by the same method for the difference, that is, the expression a minus b cubed will be equal to a cubed minus 3a squared b plus 3ab squared minus b cubed. The two given formulas are called the cube of the sum and the cube of the difference, respectively. Let's read this formula. The cube of the sum of two terms is equal to the cube of the first term, plus 3 times the square of the first and the second, plus 3 times the product of the first and the square of the second, plus the cube of the second term. This formula reads similarly. Now let's consider this example. We want to cube a given expression. We need to use a formula. The cube of the first expression, x cubed, plus triple the square of the first and the second, 3x squared, plus the triple product of the first and the square of the second, 3x by 1 squared, that's still 3x, plus the cube of the second expression. Let's consider two more formulas. Let's now multiply the polynomial a plus b by the next polynomial, a squared minus ab plus b squared, and expand this expression. A cubed minus a squared b plus ab squared multiplied by b plus a squared b. minus ab squared plus b cubed. Note that the terms a squared b cancel out. The same with these terms. A cubed plus b cubed remains. If we write it in reverse order, then we get the formula a cubed plus b cubed equal to a plus b, a squared minus ab, plus b squared. This formula is called the sum of cubes of two expressions. We can get exactly the same formula for the difference. The difference of the cubes of two expressions. It will be equal to a minus b, a squared. It will be plus ab here, plus b squared. The sum of the cubes of two expressions is the product of the sum of these expressions and the incomplete square of their difference. This bracket is called the incomplete square of the difference, because if we would have 2 here, we would get the formula for the square of the difference. In this case, it does not exist, and therefore this expression is called the incomplete square of the difference. Accordingly, this expression is called the incomplete square of the sum. The difference of the cubes of two expressions is equal to the product of the difference of these expressions and the incomplete square of the sum. Let's take a look at this example. Let's write this expression down according to the formula. We get that 8x cubed is 2x cubed minus y cubed. So we can write it down as the difference of the cubes of the two expressions. The difference of cubes is equal to the product of the difference of these expressions by the incomplete square of their sum. Incomplete square 4x squared plus the product 2xy plus y squared. We have studied the 7 formulas of reduced multiplication. You see them on the board, with the reduced form. Every student must know these formulas. In conclusion, I would just say that despite the fact that we consider this formula from left to right, it is equivalent as we can consider it from right to left. Often in many tasks, we will not use this expansion of certain expressions by a given formula, but vice versa. We will collapse the formula by a given expression. It will be useful for certain tasks. This video lesson is over.